we're talking about graphing in this chapter. So we'll look at parent functions, transformations, a lot of things that you did last year. However, last year you really only did transformations with like x squared and an absolute value of x. You didn't really have a ton of functions we used, so we are going to expand it a little bit and look at a few more things. So today we're going to focus on the common functions that we will be seeing. First, we do have a definition. We're going to talk about where things are continuous or continuity. So basically, the very informal definition is what you might guess. It's continuous if you can draw it without picking up your pencil. Okay? It's not a great definition. If you want a more precise one, take calculus and we'll give a more precise definition. But for our purposes, if you can draw it without picking up your pencil, it's a continuous function. We will use interval notation when describing this. So we always use the x values in the interval notation. The only time we use y for anything is if we're talking about a range. Otherwise, if I'm saying give me the interval where it's continuous, we will use x's only. And so interval notation is what we have been doing. Left to right, small to large. We know parenthesis means not equal to, bracket means it is equal to, so we're sticking with that for everything here. So first I'm just going to put up some graphs and we're going to look at them and identify where they are continuous. On A, I apologize, it is really hard to see, but this is an open circle at 0, 2. I know on your paper, especially when it shrank down to print, you can't really tell that, but that one's an open circle. So can you draw this entire thing without picking up your pencil? No, because it's an open circle, you have to jump over that point. So if I want to know the interval of continuity, where it's continuous, we're giving the x values. It's continuous until I get here. So it's coming from negative infinity. This right here is when x is 0. It's an open circle at 0, so it gets a parenthesis. Union, it's continuous again after 0 forever. So it's continuous from negative infinity to 0, union 0 to infinity. Everywhere except 0. All right, on B. So we have this zigzag. There are no open circles here. So could you draw that entire thing without picking up your pencil?
Yes.
Yes. So where would we say it is continuous? Mm-hmm. C. We have a line with a hole in it. So where is this one continuous?
Negative what? Is it 0? 2. Or 2?
Mm-hmm.
I don't know.
Union
Oh,
2 to positive infinity. It's continuous everywhere except at 2. All right, what about the last one? Right, it's just a parabola. It is continuous everywhere. All right, do you guys understand what it means to be continuous?
Yeah.
Yeah.
Yeah. Second thing we're going to talk about, increasing, decreasing, and constant. So you've done this with lines. If a line is increasing, it's rising. If it's decreasing, it's falling. What's a constant?
No change.
Horizontal line, no change. Again, when we're talking about these, we use the x values in the interval. Okay, so increasing just means as you go from left to right, your graph is going up. Decreasing It's going down, constant is no change. You do have to be a little careful. If I draw this, people want to tell me that's decreasing because I drew a line going down. Yeah, you have to go from left to right. As I travel left to right, it's rising. So don't just look at the arrow if the arrow is pointing up or down. Think about if I go from left to right, what am I going to be doing here? So this line would be increasing.
This was the beginning of all my problems in algebra 2.
Not going left to right, decreasing and constant. So we will use that as well. Okay, so now we're going to get into our common functions. The first one is called the identity function, f of x equals x, or f of x is the same as what variable? Y, so y equals x. We should be able to graph that pretty easily. Y equals x, what is it?
It's a straight line.
It's a line. What's your y-intercept?
0.
0. Slope is?
0.
1. So you start at 0, 0, up 1, over 1. I don't draw straight lines very well, so I put a lot of points on mine, but
Oh, my pencil.
okay. What would be the domain of that line?
All the numbers.
And we're sticking with interval notation for everything now, so it goes on forever in both directions, so negative infinity to positive infinity.
Same as the range.
And range is also the same. Is this line increasing, decreasing, or constant? Increasing. And it's always increasing, so we could say it's increasing from negative infinity to positive infinity. Is this one continuous?
Yes.
Yes, you could draw the whole thing without picking up your pencil. So it is a continuous function. All right. The next one, the square function. F of x equals x squared. It's a parabola. My rule, I'm going to require a minimum of 3 exact points. So I know you can graph x squared on your calculator and get a picture of what it looks like, but I want some exact points, so make sure you can do those. A lot of times, some people write out t-charts, some people just kind of talk through it in their head. Whatever works for you, I don't care. I'm not going to require you to show me a t-chart.
Let's go.
If you put in 0, what's 0 squared?
0.
0, 0. If you put in 1,
1,
if we put in 2,
2.
4.
What? Oh, wait.
2 squared
My
is
bad, I
4.
went the other way.
I'm going to go ahead and put in 3 just because I already have the grid ready for you.
It is what?
3 squared is
9.
9.
Yeah.
Everybody see where I'm getting these points. I'm just plugging them into x squared. So what's negative 1 squared?
1.
What's negative 2 squared?
4.
Positive 4. Negative 2 times negative 2 is positive 4. What's negative 3 squared?
9.
Positive 9.
I just go by on, it goes by the same thing on each side. One's 3s and then 5s.
That seems more complicated than just squaring numbers.
Nah.
Is this one continuous?
Yes.
Domain. As I go from left to right, what x's do we hit? Range. As I go from the bottom up, the lowest point is?
0.
And it goes up forever?
Positive.
Bracket at 0.
Right. I'm not expecting you to memorize domains and ranges on these. What I'm expecting is that if you had a graph and we're looking at it, could you give me the domain and range from that graph? Okay. Increasing, decreasing, constant. What does this function start out doing?
Decreasing.
Decreasing because it's falling. So it's coming from negative infinity
0.
and stops at 0.
Put
So-
an O in parentheses because it's at the lowest point.
So technically with increasing and decreasing, it does not matter if you do a parenthesis or a bracket. The reasoning is that at a particular point you're not going up or down, you're just right there. So As long as it's not an open circle, you could do either, so you could put it with a bracket, or you can do the parenthesis. It's not going to matter. They are equivalent here. Then what does it start doing after 0? Increases from 0 to infinity. Again, the 0 could get a parenthesis or a bracket. It's really just kind of depends on the textbook you use, which one they use. So I don't care. So far, so good? Alright, let's look at,
Isn't this like the sideways S?
Oh, yeah. It's the chair.
so the cube function. So we need to get exact points. You can write them out. You can just talk through them in your head. 0 to the third. 1 to the third. 2 to the third.
8.
-1 to the third.
-1.
-1. -2 to the third. Oops, that is. So we get this chair function. What would be the domain of that?
Infinite positive.
Keeps going in both directions. What about our range?
Negative infinite positive.
Same thing, because we have one end going up and one end going down. Increasing, decreasing, constant.
Always increase.
Always increasing. As I go from left to right, this thing is rising, and that never changes. Okay, so let's do a square root function. Can you do the square root of negative numbers? No, that's imaginary. So we can't plug in any negatives. Let's start with 0. Square root of 0. Square root of 1. What's another number we can do the square root of easily?
4.
Square root of 4 is?
2.
And square root of
9.
9 is?
3.
Does everybody know where I'm getting my points? And we said you can't get negative, so it does not extend in the negative direction. It only goes this one way. So if we look at that, domain and range, so domain is left to right, so it's starting at 0 and going to infinity. Range is bottom to top, so if I'm coming from the bottom, the first thing we hit is 0, and then it goes to infinity. And I think I already heard somebody say it, but what's this graph doing? Increasing, decreasing, increasing. And you list the x values, so starting at 0 and going to infinity.
Oh my god.
All right.
I just did that on the whole one.
Just a few more. Cube root. Can you do the cube root of negative numbers?
Yes.
Yes. You can't do an even root, like a square root, fourth root, sixth root. That's where you get the i's. But an odd root, you can't have negatives. So we have to plug in positives and negatives here. All right, so if we start with 0. Cube root of 0.
0.
Cube root of 1.
1. 8.
Okay. 8 is the perfect cube, so the cube root of 8 is 2. And then we could do negative, so the cube root of negative 1. And the cube root of negative 8. What would be the domain? And the range. This end's going down, that end's going up. Increasing, decreasing, or constant? I want you guys to come up with the graph for the next one, the absolute value function. It's one you graphed a lot in Algebra 2. So get your points, draw the graph, see if you can do the domain and range for it. Absolute value of 0 is 1, 2, negative 1, negative 2. So you get that V. Domain.
Zero.
Domain, left to right.
Oh, sorry.
Okay, range, the Y, so starting at the bottom, the first thing we hit is
0.
we touch it so it gets a bracket, comma, positive. Increasing, decreasing, constant. What does this start out doing? Decreasing from,
Zero.
and again, 0 can have parentheses bracket, it doesn't matter. And then after 0,
0.
all right, so these are all the common functions. In the next section, we'll start doing transformations with these things. So you could see any of them. Anytime I ask you to graph them, I will be looking for at a minimum 3 exact points. So make sure you know how to get those exact points on your graph. And of course, you can always do more if you need it to help you figure out for sure what the graph looks like. All right, here's my next question for you. Say I take the equation x equals y squared. How is that different than the equations we have been doing? All of the others were f of x or y equals something. If I'm going to make a t-chart for this one, which one would you want to plug in your variables for?
Or X. No, yes, Y.
Probably the y. Okay, so let's put in some numbers. All right, so if I put in 0, 0 squared is
0.
0. If I put in a 1, 1 squared,
1.
2 squared,
4.
negative 1 squared,
1.
negative 2 squared. If we plot 0, 0, 1, 1, 4, 2, 1, negative 1, 4, negative 2. What am I getting?
It's like an inequality.
Sideways parabola.
Yeah. We know a parabola is y equals x squared. So when I did x equals y squared, I flipped the x and y. It flipped my parabola on its side.
Is it possible to graph this on a calculator?
No. Well,
The calculator
yes,
won't let you.
but on a calculator, it has to be or y equals to graph it. So you would have to solve for y. And so to do that, you would have to add a square root. Anytime you put in a square root, you have to do plus and minus. So to graph it on the calculator, your y sub 1 would have to be the square root of x, and then you would have to do a second equation for a negative square root of x to graph it on the calculator. It is a little more complicated. Calculator likes y equals, so that's our only option. Is this one a function? No. How do you know that?
The vertical line.
Yeah. It fails the vertical line test, so that one is not a function. That's why we're not doing transformations with this. It's not a function.
Oh, you can only do transformations with functions?
Well,
It's easy.
we're looking with function notation and everything, so those require it. Okay. I have quite a bit of time left. I'm going to do just a little bit more. Tomorrow we're really going to talk about symmetry a lot, but I might introduce this just a little bit today, and then I'm still going to give you guys time to get your homework done in class, okay? All right, so symmetry. There are 3 different kinds of symmetry that we're going to look at. The first one is symmetric to the y-axis. Look back through all of those graphs that we've drawn. When I say symmetric to the y-axis, that means if you fold this thing on the y-axis, it overlaps itself. Are any of these functions symmetric on the y-axis?
Yes. Absolute value.
The absolute value and the parabola. Do you guys see if I fold this on that y-axis, the 2 sides are the same? So what happens if you look at these points, when you put in a positive 1 and a negative 1, you get the same thing. When I put in a positive 2 and a negative 2, we get the same thing. So if something is symmetric to the y-axis, when your x is positive or negative, it gives you the exact same value. So just for an example, that absolute value. The absolute value positive 1 and negative 1 is the same. That's what it means to be symmetric to the y. It's one thing to look at a graph and realize it. It's a little bit different if you have to focus on an equation. So in terms of a graph, we can just say, okay, if I fold it, does it work? With an equation, we have to check if positive x and negative x give us the same answer out. Look at the graphs we've drawn. Are any of them symmetric to the x-axis? Not quite. If you fold it on the x, it doesn't overlap. X equals y squared. If I fold this on the x-axis, does it overlap? Okay, so what happens is when our y is positive or negative, it equals the same thing. So on these, we would check to see if positive and negative y gives us the same answer. And again, what we're looking for is if you fold your graph on the x-axis, does it overlap? Is it going to be a function if it's symmetric to the x-axis? No. It would always fail the vertical line test if that worked. Symmetric to the origin. So symmetry to the origin requires you to flip over both the x and the y-axis. So if I took any of these graphs and flipped it over both the x and the y, would any of those overlap themselves? The cube root. Okay, if I look at this, if I just flipped it over the x, then it kind of looks like that. And then if I flip that over the y, it overlaps the original. There's another one.
Square root.
Yes. Or I guess 2 more. The identity function would work, and the cube works. You know, if you flip it over the x, it looks like this. Flip it over the y, it overlaps itself. The identity, if you flip it over the x, it looks like this. Then flip it over the y, it overlaps. So if it's symmetry to the origin, it basically requires 2 flips to get back to the original. When you look at those points, like on the cube root, I had points 1, 1, and -1, -1. I had 8, 2, and -8, -2. What did we do to both the x and the y? Switch the sign on both the x and the y. So if it's the or symmetric to the origin, you have to make your x negative and your y negative to get back to the original function. And so an example of that, like we said, is the cube function. All right, do you guys understand what I mean when I talk about the three types of symmetry? Okay. With symmetry, we'll come back to that tomorrow. I'm just going to go over the definitions today. We'll do the examples on this tomorrow. We can talk about even and odd. So even functions are symmetric to the y-axis. We said if it's symmetric to the y, both a positive x and a negative x equal the same thing. Odd functions are symmetric to the origin. I just remember the O's go together. Odd is origin. And again, we said what that means is if the x is negative, the y has to be negative as well. I don't have a word for symmetric to the x-axis because can a function be symmetric to the x-axis? No. So when I'm talking about symmetry, I might ask you, is it even, odd, if I'm looking at functions, or I might say, is it symmetric to the x-axis, y-axis, or origin? I'm really asking the same thing in both scenarios. And we'll look at those problems tomorrow. Do you guys have any questions over what I've done today? So there is a handout posted on Classroom. It is not very long. It's just over those main